next up is Ambili. I'm going to hope we've got her on the line and that she's there.
I can see two of her for a change. So
hey,
there we are. There? Hi, Ambili.
Okay, so Ambili, I'm going to stop sharing and hopefully your slides come through. We don't lose internet connection and we're all good. Let's give this a shot. Come on.
Good luck.
I think I'm good this time. My audio is going to come through another connection to my phone. Yeah, so I'll just turn off the video for now and continue with the session. Yeah. All right.
Perfect. Are you've got your slides there as well, haven't you? Or do you need me to do that?
Let me try that first. I think it will work this time.
Okay, I'll come off camera. Everyone, please enjoy Ambili, and we will.
Okay, so are we intact?
We are indeed. You are good to go.
All right. It's been a real, challenging day, but I think it's going to end fine. So I just got rid of some of the animations, which I think was a troublemaker. And I can see more participants now. So we'll just quickly introduce my topic and get on with the content. So today we're going to have a presentation on machine learning for prediction, especially for those who are new to machine learning and are scared of, the big world of the complex world of machine learning. The good news is that Oracle Analytics Cloud gives you the power to explore and really reap in the benefit of all the functionalities there, the no-code way. So that is the highlight of the entire session. You're just going to see how exactly we do that. And the major chunk of the whole session is going to be a live demo wherein you will experience all the power, through the examples that we're going to cover. So I think I had a lot of introduction already, so I'll just skip this part and get on with my topic right now. So straight into the topic. So the whole session, we are primarily focusing on predictive analytics. Now, predictive analytics, as many of you would already be knowing, is a piece of hot cake. I must say this because you can see here the graph that represents the first bar is showing the data of 2020, wherein the analytics market, the predictive analytics market is, at 5.29 billion. And we have a big scope of growth by 2028 up to a whopping 41.52 billion. So this is the power of, the predictive analytics global market. And that's exactly why we are also, seeing a lot of technological development and, features which are being enriched in all the tools which are there in the market, which kind of explores the ways in which predictive analytics can be utilized, right? So what is predictive analytics? By definition, it is nothing but, it's a way in which we analyze, the historical data using all the statistics and data mining to predict future outcomes. So that is the definition. And we are going to see exactly how we are going to do that and how simple it is, made simple by Oracle Analytics Cloud, right? So before we move on to that, a quick comparison on the traditional programming versus machine learning. Now, these are all for those people who are pretty much new with machine learning, to just set the context. So traditional programming, as you all must be aware already, that it's more of a manual process, right? A programmer kind of creates a program and we have an input data. So input data comes in and we have, a programmer who creates a program which finally gives us an output, right? When the program is executed. Now, with machine learning, what exactly happens on the other hand is that the input data and output data both are fed into the system, and that's, or into an algorithm, that's how we call it, and that creates a program, or what we refer to as a model, which automatically formulates rules from the data which which is fed into the system later on. And this is very powerful, mainly because the whole task kind of gets simplified into identifying the input and output data which historically exists in an organization, And machine learning creates a model which can be used to run your business and predict all your future outcomes. So this is the whole, the power of machine learning, which is really making a big change in the market and in the business, right? Now, literally, in a nutshell, the way it is represented here, what we are talking about next is, the algorithms that comprises within machine learning. Now, these terminologies you must have already heard of. Now, we have like supervised, unsupervised, and reinforcement learning, right? Quickly, just to understand what each are, because in our live demo and also in the tools, whoever, even if you don't understand machine learning in depth, it is good to know where each of these algorithms really play a part, right? So that you can choose it correctly. And as per your scenario, you can choose a relevant algorithms, right? So just to build your understanding here, let's talk about supervised learning. So this is mainly a task-driven algorithm, mainly to predict the next values, or say a win-loss, or what happens next. So that kind of supervised predicted outcome is what is resulted by supervised learning. And here mainly we work with labeled data. And I think there was already a quiz that went in, and most of you have correctly guessed the answer to. So I believe you all have an understanding already. So just for the other lot, one easy example that you can relate to is supervised learning is mainly what is used in the categorization of spam emails. Like you might be categorizing or labeling the email, certain emails as spam and no spam or not spam, right? So what happens in the background is classifying these emails. When the user classifies his emails, it kind of helps the machine to label the future emails in relevant category based on how the user has classified beforehand. So pretty much you can relate to that use case when it comes to supervised learning use cases, right? And moving on to unsupervised learning. Why we call it as unsupervised is because they don't aim at a specific goal, but it's more of an more exploratory in nature. Now, mainly it is data driven, which is another difference from supervised, which is task driven. And we kind of use of unsupervised learning for identifying clusters. I mean, just because I'm seeing unstable again, Abby, can you confirm if I'm audible? All good so far?
Yes, we can hear you fine, Ambili.
All right, that's great news. So moving on, the third type is reinforcement learning. So that is the third way in which the machine learning algorithms can be used, wherein we learn from our previous mistakes. So it is more or less similar to supervised machine learning. However, what happens is instead of providing an initial set of data for learning and validation, the learning in this way is continuous, and the model kind of changes based on ongoing changes in data. So what happens is it all kind of works from an agent or the machine which is in question. And what happens is it learns from its environment and all the interaction that happens with it. And the agent kind of receives penalties if at all it is performing incorrectly, and rewards if it is performing correctly. So based on these penalties and rewards, it kind of builds on the experience, and that is the whole fundamental of the reinforcement learning. So moving on, quickly let me show you the major use cases, because we need to exactly know where the classification or regression ways can be used under supervised learning. So mainly supervised learning makes use of these ways or techniques, that is classification and regression. Mainly classification comes under use cases like identifying high value customers, or suppose say you have a lot of images and you want to classify them correctly, or say you want to detect the fraud instances correctly. So these are all like classification use cases which are very much relevant in supervised learning. And under regression, you can relate to the predictions that we do for, say, the housing prices in the market, and say how the population growth predictions happen. So these are all like some very famous supervised learning use cases. And moving on to unsupervised, there are mainly clustering and dimensionality reduction techniques that comes into picture here. So clustering is nothing but it kind of reveals natural groups within a data set. And we have a lot of important use cases here, like the customer segmentation or say the document similarity detection. So these are all like some of the major use cases in here. And when it comes to dimensionality reduction, you can relate it to use cases wherein we are trying to visualize a big data picture in a dimensionally reduced way, or a kind of a meaningful compression of a big image. So these are all some of the major use cases which comes under this. So that was quickly, the foundation. We were just setting the foundation for all you participants with respect to machine learning. Now we are going to deep dive into machine learning and Oracle Analytics. Yeah. So Oracle Analytics, when it comes to the capabilities, right, especially with machine learning, it initially starts with connecting to diverse data sources. So any data sources which you can remember, recollect in the market, you name it and OSC has it. That's how I have seen it there. Any kind of databases, PaaS, SaaS application, big data sources. So everything which is quite relevant in the market, we are able to connect through OAC. And there are many one-click advanced analytics features which are inherent in Oracle Analytics Cloud. So I have just listed down some of the major ones here, which we are also going to see in our demo shortly. So some of them are the overlaying of reference lines, trend lines, or cluster, identifying clusters or outliers, everything just with a button click. And also, just a button click away is a complex, features like forecasting on time series data. And suppose, say, if you want to build scenarios based on pre-built model with a data flow, even that is possible. And another major feature, which you all must be aware of if you're familiar with OAC, it is the explain feature, which also uses machine learning algorithms in the background. And it kind of auto explains the attributes or the measures which we try to gain more insight about. All these insights are auto generated. And we can see a lot of categories like influencers or prediction, confidence, or anomaly detection. So everything happens in an auto-generated way with the explain feature. So these are all some of the major features which you should know when you're exploring OAC. Now, here what you're seeing is and machine learning modeling, what exactly is a typical process which is used within, right? So whenever we are trying to train or apply a machine learning model, each of these training tasks, have a set of algorithms or scripts that you choose from. Now, everything starts from, initially building a business understanding, wherein what happens is nothing but we define the objectives or define the success criteria which we are expecting, right? And then goes with the data understanding, wherein we kind of capture the data, we describe it, we explore the data, which is mainly we're talking about the data sources which on top of which we'll be working on. And the third step is the data preparation. So data preparation, okay, so just before going to data preparation, the second step, which is data understanding, that's where, the explain feature really comes in handy. And moving on to data preparation, wherein we can do a lot of things like, selecting relevant column information. If at all our data set is quite huge and we don't want to work with entire stuff, right? We have the capability of selecting what we require and, clean up the data. We can construct the data in a way that is more relevant to the use case. We can combine data from various data sources. So everything you can do here. And also a lot of transformation function capabilities are also inherent, at this step, right? So after that, we move on to the modeling. So modeling is mainly done with the help of a feature called data flow. So we'll be seeing it shortly. So data flow creation, when we do that, we initially do that, to build a model. And we kind of train the model with a particular training data set in this particular step. And then we move on to create another data flow wherein we apply the model and we kind of see how exactly the predicted outcomes or outputs come when we apply the created model on a new data set, right, which is kind of a test or a production data set, right? And we can evaluate all these models that we have created. So there are a lot of ways or metrics which OAC provides, which help you evaluate it. And when you are we have confirmed and verified everything about the model, you can actually go about with the deployment. So this is a typical process that is involved. And so now, specifically, we are also going to see the ML workflow, which is inherent in the predictive model creation. So after this slide, it's a live demo, and you're all going to see whatever we talked about. We're going to see it in real. Okay. So here we're talking about creating a predictive model. So the steps to create a prediction is pretty easy. We identify the relevant training data sets. Then we create the training model. The training models are created using the data flows, as I just mentioned before in the previous slide. And we kind of do appropriate training with the help of model and algorithms, which we choose in that step. And then we can go in for inspection of the model and then go ahead confidently with applying the model, which again happens with the help of a data flow. And finally, we have an optional step, which Zika also had mentioned in his session. It is about creating the scenario wherein, we kind of create a dynamic way to refer to the predicted output. So this is on a high level what you need to know before we actually plunge into the live demo. So it's time for live demo, and we are going to see, all these scenarios live on Oracle Analytics Cloud 6.4 version. And let me straight away move on to our environment. Yeah. So just refreshing because it's been some time since I logged in. So this is our OAC environment, and let's initially start off with creating the data sets. So creating data sets, and now what exactly I'm going to try doing is with the help of this live demo, which is going to be pretty quick and fast. But I just want you all to grasp and know for real how simple it is. Whatever we explained right now, the workflow, the typical process involved. Even if to understand, there's a lot in the background, but when you have to actually work on it, it is pretty simple, and anybody can just go there and start trying it out without any preparation. So let me show you a demo of that. So whenever you're creating or connecting to a data set, we can do that over here. So it can be, if at all it is a CSV or a text file, we can just drop the data file in here. Or if you have any, if you want to specifically connect to any database and you have the connection string and all the information or the parameter information that is required, you can also create a connection. Let me just quickly show you here. So we have the whole, as I told you in one of the slides, anything you name it and we have it here. So any sort of data source connection is possible out here if at all, if you have the relevant parameter information. And even the connection parameters which are required are pretty much straightforward and nothing complex, and everything that is basically used, that's all that you need here. So for our demo, I'm going to try connecting to the Oracle DB here. So we have a connection which is already created. So you can see the Oracle database is whatever schemas which are all in there. It's all listed in, and it's just a matter of choosing what you want here. All right. So this particular HR schema is having all these tables in there. I'm just trying to go and pull in employees and departments table. So when I'm choosing two tables, in here. So automatically what happens is an auto join. You can see it is enabled here. So a join is automatically created, and between these two tables, Oracle Analytics Cloud, so it is kind of pulled in department ID as a joining condition, which is correct. I'm not going to change that. So once this data set is, you have confirmed that this is what you want to work with, you can just go about saving it. Yeah. So the new data set, let me save it as employee department demo. All right. So let me save that here. So once you create a data set, you'll be able to go back and see it under data. And you can do a lot of things, if you say, let's just access this particular data. And initially I was talking about a lot of data preparation, cleaning steps, right? So if at all I access that particular data, I'm just pulling in the information here. I'm going to edit it. So you can see the entire information loaded out there. And it's all just, pretty easy and nothing complex about it. You'll be able to really understand what is what just by looking at it, right? So the first things what we normally do as a data cleanup or preparation is, because automatically all these columns are, mapped under, either attributes or measures. So there could be some wrong mappings. If yes, then we can, do all those corrections at this particular point. So over here, I can see it is all fine for now. Yeah, so if it all say I'm doing some change at this particular point, there are lots that you can do here. But any particular change, now suppose I'm just, temporarily changing the value to an attribute. So you can say quickly a step gets added in here. All right, so that kind of happens not when it is a database. So let me just show that to you, what I just wanted to show you with my Excel or CSV data source, which I'll be connecting shortly. So here what I have done is, have loaded the data set, and then I can just go about creating the workbook. So I'm not going to save the change that I have made and just directly going to create a workbook. So within this workbook option, wherein we are in the visualize tab, right? Let me just quickly pull in information like the department name, employee ID, and the department name. So I can just control click and pull it here. So both the columns are coming in, and automatically the auto visualization is pulled in as a table format, right? So now any visualization that you want, it's just a click away here. So let me try to take it as a bar chart. Okay, 1 second. So let me initially go into the table one itself. And okay, suppose say you want to have the departments coming in a different color. So it's a lot of settings that you can do in here. So this is particularly a demo of how the data sources can be connected to easily, right? So you have used a data set which we created, and that is now used into a visualization here. Now quickly going back to the second step, wherein I'm trying to next create a data flow. Okay, so within the data flow, there's a lot of capabilities that is still inherent. Now, again, let me just go back, pull in the same data set that we have created just now. So employee department demo. So that is a data set that we just created, right? Now I'm going to select all the columns here. And suppose say you want to do some, some kind of sort of transformation or filtration, right? Let me just add a filter here. Now, this is how you create a data flow, wherein you have a lot of capabilities that, you can just explore. Now, over here, I'm going to try adding, say, the department name. So suppose say I want to create a filter based on the department name. I can just, pull in the particular column that I need, then select them. So I'm kind of, what I'm doing here is I'm filtering the data based on the department names, which I really want to work with, right? So I just chosen 4, and you can do a save data here. So the save data, when you do that, it kind of, give you the final output, which will be the filtered data set, right? So employee, department, filtered, right? So I'm just going to give it that way. And if I save it here, now this is a data flow. So the data flow I have created with just a filter added in there, right? So filter data flow. So we're not reached the machine learning capabilities yet, but just I'm going to show you what I'm showing is a quick demonstration of the data flow capabilities. All right. Now, whenever we save the data flow, we can just run the data flow in here to wherein, the exact sequence of events are executed, and eventually the new data set will be created, and you can find it right under data. So this is the employee department filter data we just now got created when we ran the data flow. So that is about how easy it is to create a data flow, and we can do a lot of things here. So we just added a step for filter being added, right? Similarly, we have addition of columns, or we can add a new data set in there and aggregate data. I mean, a lot of things that you can do. So basically, data flow is nothing but a sequence of steps, right? So even the data flow, you can access it, in this particular tab. So filter. So these are all like different steps that we can add. So if at all you want to modify this, eventually all these steps can be done, at a later point in time. Anything like transforming a column, merging columns. So there are a lot of things that you can actually do at a data flow step. Now here, specifically with respect to machine learning model creation, we are going to create 2 data flows, all right? So let me go back and create a brand new data flow here. So let me pull in a data set which is related to the COVID forecast. Okay, so I have a training data set in here. So let me go ahead and pull that in. So whenever we pull in a data set, which we just saw another demo of, right? So we can just do all the corrections. Now this is an ID column, which I want to change it into an attribute. I just want the confirmed cases and fatalities. These are actually the measures which I want to retain, okay? So let me go ahead and add it. So when you actually add a particular data set, that is when it is exactly going to be created and going to be available for future use. Now I have added it in here. Now you can see that automatically a lot of recommendations are coming in. So these are all like one-click enrichment. If at all it is makes sense to your use case, you can go ahead and do it. Like for example, I have a date column in there. Now you can see that there are a lot of recommendations where it is asking whether I want to extract the year from the date. So let me go ahead and click this and see it is executed, and a new column has been created in there wherein only the year value is extracted. So it is this easy to do all these recommended enrichments that which is listed out there. Now, because I have added this particular step there, you can see that it is enabling the apply script option, which when I click, that particular change is getting applied to the data set. Now, quickly, let me go ahead and so this is kind of created and it is saved. So I'm saving it and going back in there. Now, what we're going to do here is, so our data set is ready. Now, let's create a new data flow. Now, this data flow will pull in our claim, the COVID data set, which we just used here, or which we just created. Now this is looking correct, and you can see, as because it's a data flow, it is prompting us to add more steps. Now, what exactly we're trying to prompt here or do here is create a model. So for creating a model, this particular data set, we are going to predict the number of fatalities based on the other columns that is already in there. So because it's a numeric prediction, let me go ahead straight away use the numeric prediction model script, and let me select the linear regression, because that is also, something that is more relevant to the numeric predictions. All right. Now, what happens when you have to create a model? It is as simple as creating the algorithm based on the use cases that you are, or what exactly you're trying to predict. If it's a numeric prediction, as we selected the numeric prediction and linear regression model training, right? The same way, it's just a matter of the right selection. And also you need to select the target column on top of which the prediction is going to be applied. So that is fatalities in my case. So I have just selected that, keeping all the other parameters intact, and moving on to the save model. So what I'm going to do here is I'm going to save it in a meaningful way. So this is COVID prediction, the predict, and numerical prediction with linear regression, and this is a model, right? So I'm just going to just copy that because it will again ask me to save the data flow. So I'm just removing this and making it a data flow. So we are good. So our model, the training model, is created here. And now how do we train it? We just need to run this particular model. So I'm right now running the particular data flow. Okay. So what is happening is that on top of a training data set, the algorithm that we have chosen is being applied, and the data flow is executed completely. So eventually it would have created a model which we can go and check in here. So machine learning is option or menu option wherein you need to go, and you can see the COVID predict MPLR model which we just created in here. Now, before we go ahead and test it on a real data, to do an actual prediction, what we should be doing, or what we can do to assure that the accuracy of the model is intact or good. So Oracle Analytic Cloud give you the option to inspect. So go to that particular model and just right click and click on inspect, which will give you this particular window wherein, in all these tabs, a lot of a wealth of information is residing. So the main ones which I want to talk about right now is the quality tab here. Now you can see a lot of metrics are visible in here. So out of these metrics, you can see the coefficient of determination, or the R square, which you can see here. That indicates the accuracy of the model. Now, if at all the percentage was 100%, it just means that the variability of the response data is around its mean. All right, so 79% for our model is a good value, and I'm happy with that, because it's sometimes it can even be lesser than 20, which means that the model is not good with respect to accuracy. But here we are good to proceed. So you can also have a look at these representation, which is nothing but residual value, count by residual value. That is what is depicted here. Now, residual values are nothing but the difference between what was predicted and what was really observed. So that kind of shows the errors which exhibits on the training data. Now that way also we are pretty good here. And also we have the other tabs. The access tab shows you who all can access this particular machine learning model that we have just created. And details are again self-explanatory. So let's move on to the more important related tab. So here you can see this is pretty much clear that it is showing which training data set we have connected to and what is the algorithm we have used in here. But on top you can see there's something called generated data. Now, what it is showing over there is data which is internal to the model. All right. So it kind of helps you to visualize the effectiveness of the model. And, it also gives you a way to visualize these metric values. Now, let me just double click. And, as soon as you double click there, what happens? It gets loaded in a new workbook. So if you want to see what exactly is in here, so let me just select these three, driver name to target and create the best visualization. So automatically it comes in with a bar chart. But just to show you what exactly is in there, let me change that to a table. Now, what happens here is these are all metrics which will show you or, help you to understand your data. Now here, it just means that our target column is fatalities, which we're trying to predict. And these are the columns, or the features on the basis of which the fatalities could have a dependency on. Now, when you see the correlation, you can see positive correlation for these two columns, which are confirmed cases and province. So how you should understand is that whenever the confirmed cases, the number of confirmed cases for COVID increases, then the fatalities number is also going to increase. So it is directly dependent on confirmed cases and province state, and it is not having a dependency on the country, region, or the date when they got infected. Now, that is pretty much we can relate to as well, right? So that's exactly how these kind of metric information have to be understood. So this is how you evaluate a model accuracy. And now that, if you're happy with the accuracy, I'm not going to save this. I'm going to go back to, that creating a new data flow, because I'm happy with the accuracy and the metrics, how the data has been pulled in. Now, next, what I'm going to do, again, just a click away, we are going to pull in a real data set or a test data set on top of which we are going to run our model. Now, this particular data set, let me just pull it here. So this is a test data set. When I load it, you can see that it is not having the fatalities column, but everything else is intact. I mean, and I have used a data set which is having all the column names as same. If at all there is a change, we need to do a mapping correctly at a later point. But for now, to make it easier, it's all same. And what is missing is only the column which we have to predict. So this data set doesn't have that. Let me just go ahead. Okay, let me change it to attribute, because this is an ID column. Only the confirmed cases is the measure right now. Let me go ahead and add it. Right, so demo. I'm going to add that here. So when I added that, all these recommendations are coming in too, which is fine. But I'll just go back and to the data flow which I was trying to create, and it is already in there. So let me just go ahead and select it. Now you can see, again, we're going back to the data flow creation page. And right now, there's a little bit of difference that you can see here. So data set, okay, it is already selected. And we have all the columns in here. And what we need to do next is, apply the model, right? So we just pull in that particular step. And this is the model that we had created, which we evaluated as good, right? So let me just click it. And that particular model is pulled in here. And you can see that there's an output value. So whatever you want to predict, the predicted value. So what is the predicted value? We are trying to predict the fatalities, right? So predicted. So I just renamed that particular column. Everything else can be the same. Now, here is where I was talking about the mapping. Now, we have a pretty simple scenario wherein all the column names are same. So we don't have to do any changes. Sometimes what happens, the data set on, which you have to test might have the names as different. So you need to map it correctly at this particular point. Now that this is also done, what we have to do is save the data. And you need to save the data to, so the predicted model output. Okay, so I'm saving the data set this way. So let me just go ahead and save it. And it is asking to save the data flow, which I'm saving again. And we are good to run the data flow. So when we run this particular data flow, what happens? The entire sequence that we have created in here that executes. So the test data set is what we are running it on top of, and we are applying the model which we have already created in the previous data flow, with the previous data flow, right? And then eventually we are saving the data, and the data, if it is saved, then see, you can see the data set name is model OP demo. So we should be able to see that in the home page, in the data menu. Yes, it has come in right there. Now what we can do, let's just create a workbook, right click, create workbook, and it loads the entire columns which are in there. And you can see that, okay, the column fatalities predicted, that is also come in there. Yeah. So, let me just pull out these two columns. Okay, 1 and 2. Right click, create best visualization. And it has given me a line chart. Now here is where, something more that I wanted to show you. Before that, let me just quickly go back to the slide. So what we have covered so far in the demo. So we saw the creation of data set, right? So this we have seen, and okay, so this, in the interest of time, I had to skip this part, but if you have any questions related to that, we can have a quick demo at that particular point. Now, you can see that in the advanced analytics, we have options to create reference lines or forecast trend line, outliers, and clusters. Now, what we can do here is, because it's a line chart, you can see how easy it is to add all these into the visualization. Now, just do a right click. You can see add statistics. And if you go select the reference line, it just shows you, the reference lines on the basis of whatever reference you choose in here. So now here the function which is applied is average. Now, if you want a reference line on the base of minimum or maximum, say we want to do it with maximum. Now the reference line shifts to, the maximum point. So similarly, this is one thing that we can do. And another capability is a trend line. Now, how exactly is it? It is a trending, right? So the trend line is also added in here. Now, this particular data really doesn't show you that very clearly, but you can see what you have to understand is whenever you want to do this forecasting or adding the cluster, identification of clusters or outliers, adding reference lines, everything is just a click away when you have the visualization with the right columns pulled in. Okay, so now forecast is nothing but another functionality. Okay, we really don't have the right data set wherein I can explain to you how it works. But if the timeline was correct, if the date value was correct, suppose say we were trying to fetch the data over years, and say we had, the data from 2000 to 2020, then the next, say 10 years or how many ever years you want to have forecast data, shown up, we will be able to easily do that, with the help of that option. So those were, what I was trying to quickly demonstrate there. And mainly we also saw how we can train and build an ML model. We reviewed the model quality, and we also compared, the comparison of model is something that we can do. Right now we created only one model, so this is not what we just did, but we can do that if at all we are going to create two models, and then the metrics values which we saw in the inspect menu, right? It is quite easy with comparing the efficiency or accuracy of two models. So that's pretty straightforward. And we also used an ML model to make predictions. Now, do I have time to go ahead with one quick demonstration of the scenario edition, or otherwise
we're starting to run out of a bit of time here, Ambili.
Okay, so I think it's just an optional step that I just wanted to show you, wherein the previous example we kind of populated a column and saved it into a database. Now we don't have to really go about doing that. There's an option of adding a scenario step. Create a scenario and dynamically that particular apply the model, and that particular predicted column gets populated. See, it's already in here, so that you can use for visualization. So that's all I wanted to show to you there. And these are nothing but the metrics. And the last slide is about what is coming up, the special features which are coming up in 2022 in OAC, specifically for advanced analytics and ML. There's a lot of interesting things underway, and mainly in Oracle Functions integration, then you will be able to call an API or a custom script as a function that is planned for the first half of 2022, and uncovering insights in unstructured text using NLP or insights within images. These are all going to be pretty simple in the second half of 2022. So this is what I had to share with you all.
That's great. Thank you. That's wow. Yeah, amazing demos.
I've got one.
We have one. Oh, yeah, go for it, Roger.
Sorry, no, you carry on, mate. There we are.
No, go for it, Roger. Go on.
Kill its mic for 5 minutes over. Who's gonna? Ambili, anonymous attendee.
Okay.
Says, can we use predictive analytics in computer vision? OpenC. I think it's saying.
OpenCV. It's a Python package.
Yeah, OpenCV. Yeah.
Okay. Can you come again, Roger? I mean, I couldn't hear the last part that clearly.
No,
so where exactly you want to apply the predictive analytics? Open?
In computer vision, OpenCV.
Is that something, Abby, you know?
Yeah, so as it stands at the minute, there's a very convoluted way to do OpenCV in OAC. So under the hood of OAC, you do have a Python engine running. So you can do new installations of packages onto that Python installation to enable OAC to do OpenCV. It's not there as a standard package of OAC, but it is possible if you want to go down that route. I know that OpenCV and image analysis work is something that's come into OAC, so it's kind of watch this space. If you really want to go down the OpenCV, you're probably looking more at the Oracle Data Science platform, where you can configure your Python environments better. You can do your continuous integration, GitHub, etc. in there, and then pull the visuals through into OAC afterwards. I love using OpenCV. If anyone's ever seen my presentation on soccer or football analytics, I use a lot of it in there. So yeah, just if you want to get into that sort of stuff, give me a shout on Slack or something, and I'm happy to take those questions offline. But I guess the answer to that is it's coming. Hang on in there if you want to use it in OAC.
Okay. I think that's all the questions are, and that's definitely why you should have answered that.
Exactly. I knew she would know it. I mean, this is something I haven't explored myself. Yeah.
But Ambili, that was superb. Thank you very much for it, and thanks for juggling around for us. I know it's been a difficult morning for you, or difficult evening for you, actually. So
yeah, thank you very much.
Thank you for
the wait, and yeah, I really enjoyed it. Yeah, thank you.